cable in this case is used to carry both the power and the data to the unit. Now, you might want to consider an example here where you have a warehouse where access points need to be installed everywhere throughout the warehouse, but specifically on the ceiling of the building. Now, obviously, there's not going to be power way up on the ceiling of a warehouse. The labor costs that would be incurred to install electrical outlets throughout this ceiling would definitely be high. Hiring an electrician as well would be expensive and very time-consuming. So, we can use Power over Ethernet to solve this type of a problem. One thing to remember about Power over Ethernet, however, is that Ethernet cables only carry data reliably for 100 meters. And for any distance more than 100 meters, Power over Ethernet is not going to be a viable solution. A lot of times, the best places to install access points or bridges for the radio frequency connectivity will have no power source, and that's really where this comes into play. Therefore, Power over Ethernet can be a great possibility for you when you run into situations like this. Now, there are going to be several options for Power over Ethernet that you want to get used to. The first one is known as a single-port DC voltage injector. We also have multi-port DC voltage injectors, as well as Ethernet switches, which are designed to inject DC voltage on each port on a given pair of pins. Although the configuration and management is generally not going to be necessary for devices that get their Power over Ethernet, there are going to be some caveats to be aware of if you decide to use Power over Ethernet. The first thing to be aware of is that there is no industry standard at all for the implementation of Power over Ethernet. And that means that manufacturers of PoE equipment have not worked together at all and agreed upon how this equipment should interface with other devices. So if you're using a wireless device like an access point, and it will be using PoE, it's recommended that you purchase the PoE device from the same manufacturer as the access point. This will hold true when considering all of your PoE devices. Second, and also very similar to this, is that the output voltage required to power a wireless LAN will differ to power a wireless LAN device is going to differ from manufacturer to manufacturer. You want to be very careful when you're dealing with using different equipment and PoE. When in doubt, ask your manufacturer or the vendor. The other thing that you have to be aware of that's definitely one of the most important caveats is the unused pins that are used to carry the power on the Ethernet port are absolutely not standardized. One manufacturer may carry power on pins 4 and 5, while another carries it on pins 7 and 8. If you connect a cable accidentally carrying power on 4 and 5 to an access point that does not accept power on those pins, the access point will not power up, and you do stand the danger of damaging equipment. So be very careful of those. Now, as far as PoE compatibility goes, there are going to be some devices that are considered to be not PoE compatible, and they can be converted to Power over Ethernet by way of what's known as a DC picker or tap. These are sometimes called active Ethernet splitters. This device is actually going to pick off the DC voltage that has been injected into the Cat5 cable by the injector and actually make it available to the equipment through the regular DC power jack. However, in order to use Power over Ethernet, one of the following device combinations has got to be used: an injector plus a PoE compatible device, or an injector plus a non-PoE compatible device plus a picker. And there are a couple of types of injectors that you can use: passive and fault protected. Each type is typically available in a variety of voltage levels and number of ports. Passive injectors place a DC voltage onto the Cat5 cable. Those devices provide no fault short circuit protection at all. Fault-protected injectors, however, provide continuous fault monitoring and protection to detect short circuits as well as overcurrent conditions in the Cat5 cable. And those are probably the better ones to get. There's also some types of picker or taps that can be used: passive and regulated. A passive tap simply takes the voltage from the Cat5 cable and directs it to the equipment for direct connection over the standard DC output pin. Therefore, if the injector injects 48 volts DC, then 48 volts DC is produced at the output of the passive tap. Whereas a regulated tap takes the voltage on the Cat5 cable and converts it to another voltage. Now, you're going to have several regulated voltages that you can set on a regulated tap: 5 volts, 6 volts, and 12 volts DC, allowing a wide variety of different non-PoE equipment choices to be made and to be powered through the Cat5 cable. So with PoE compatibility, what we're focused on are devices that do not support PoE, yet we might have power over Ethernet switches that we want to use and be able, of course, to send the data send the power over the Ethernet cable along with the data. This allows us to have this extra level of flexibility. One thing to realize is that most of the time, if you're dealing with a high-end enterprise-level access point or wireless bridge, you will be able to support direct power over Ethernet through a powered switch. All we're trying to do here is to identify some flexible measures in case we do have some sort of an access point that does not support PoE, we can still use our powered devices to be able to transport power over the Ethernet cable. But in most high-end situations, you will be able to plug in, for instance, a Cisco 1200 access point directly into the powered Ethernet switch. It'll pull its power just fine, and that allows it to run anywhere where you have switch compatibility and connectivity within 100 meters. Now, there are going to be some caveats with voltage pinout standards that you want to be aware of. Right now, the IEEE is working on a standard that is forthcoming known as the 802.3 AF. Now, this is designed for PoE, and what it is going to be a definitive standard that allows vendors to identify what pins they're going to use for Ethernet transmissions of power. However, at present, different vendors are going to use different voltages as well as different pin configurations to provide the DC power. Very important that you do select your PoE devices for each piece of equipment that you do plan to power through the Cat5 cable. Right now, with the 802.3 AF standard, the IEEE has standardized on the use of 48 volts DC as the injected PoE voltage. The use of this higher voltage does reduce the current that flows through the Cat5 cable and therefore increases the load and increases the Cat5 cable length limitations. Where the maximum cable length has not yet been a major consideration, some other vendors have chosen to use 24 volts DC or even 12 volts DC instead of the 48 volt DC standard as their injected voltage. The other thing that you've got to realize is that as these vendor voltages vary, we may have to go through a series of equipment matching to make sure that we use the same vendor's equipment all the way through so that we don't have to buy external devices to be able to remain compatible. Once the IEEE 802.3 AF standard is fully aware and, of course, has become the de facto, we won't have to worry so much about this variation in our pinout standards for both voltage and pin sets. Another thing that is very important with pinouts is fault protection. The primary purpose of fault protection is to protect the cable and the equipment and the power supply in the event of a fault or a short circuit. Now, during normal operation, a fault may never occur in a Cat5 cable. However, there are several ways that it could be introduced into the Cat5 cable, such as the attached device just simply being totally incompatible with PoE and may have some non-standard or possibly defective connection that does short-circuit the PoE conductors. At present, most non-PoE devices have no connection on the PoE pins, and therefore, they're not going to have an issue with the pinouts or with fault protection. But incorrectly wired Cat5 cabling is another example. Cut or crushed Cat5 cabling is another example in which the insulation of one of the conductors have come in contact with another conducting material that may be carrying power. This can actually cause a fault. During any fault condition, the fault protection that we have with PoE is going to shut off the DC voltage that's been injected into the cable. Fault protection circuit operation will vary from model to model on different devices, so be aware of how your particular chosen vendor uses this voltage. Some models will continuously monitor the cable and will restore power automatically once the fault is removed. However, some models may not do this at all and may have to be manually reset or rebooted before they'll begin to actually process data once again, or even to enable that particular port. The same thing is going to hold true with just about any device that you do plug in to a PoE port. And it is very convenient to use power over Ethernet, but you got to remember the caveats and you have to remember the limitations of the cable. Right now, we do have some issue with standardization, so the best that you can do is to buy same vendor equipment whenever possible, the same type of access point as the powered switch, and that almost guarantees that they're going to be using the same pinouts. If you're not using the same pinouts, you're going to have to change the way that you actually use power over Ethernet, and most of the devices are not configurable as far as which pins they use for power, so we've got to make sure that we have some standardization there because of the lack of standards that we have right now in the industry. So our wireless LAN has two sides. It has the radio side, radio frequency, and of course it has our network side, typically Ethernet. What we want to focus on right now is understanding our wireless LAN accessories, understanding the radio frequency side. We look at connectors and cables and the way that we actually plug our antennas in. It's very important to be able to calculate what our overall impedances are going to be,